When we open the software, we're welcomed with the interface as well as a dialog box to create a new model. In case this doesn't appear, when you click on this new model icon, you can recall it again. Now here we see we have to enter a model name. Say for example, let's name it as example 1. And you have a project name, you have the folder wherein the file is saved, you have the type of the model being 3D. The load cases and combinations are based on ASCE 7 2016. We have a drop down menu which helps us to access other standards which deals with load cases and combinations. Since we are following ASCE for the entire course, we choose this option. Now we can manipulate the orientation of the z-axis. In this case, the global z has been set upwards and the local z has been set as downwards. Click OK. We have an option called template. Template is used if we are dealing with a particular type of structure throughout our project, or if we are into modeling a similar type of structure all the time, we can create a template which has some of these options pre-selected, and then we do not have to keep changing all the time. We can add some comment here. To change the units, we have the units and decimal places. When you click on this icon, the units by default is imperial. We can change to metric if you want to. As a note, you have to keep in mind that the AISE manual that we are following is completely in the imperial units. Therefore, we use imperial units for the course as well as the software. Click OK, and you see that the interface has been prepared for us to model, apply loads as well as analysis, followed by design. Now just take a quick look at the interface. Right here we see some file options, edit, view tabs that you are familiar to. As we progress in the course, we see some important options that we need to take from here. Regarding the modeling, you can create new node, new line, new member, new polyline. The option that we are going to be using the most from here is new single member. You can create surfaces from this option. You can create loads and load combinations from here. These are some view options from where you can change your view to isometric perspective, and then you can have some 2D views from here and some other display options. On the left hand side, we have a project navigator. The project navigator is where the changes in the model that we make, or the changes that we make in the viewport, are properly documented on the left hand side. The moment we create a new member, the member folder here is updated. The moment we create a node, the node folder is updated. The moment we do anything in the model gets updated on the project navigator. Now, as we scroll to the bottom, we see that there is a box called add-on modules. The technique used in the software to do design is as follows. We do all the modeling, load application, and structural analysis using the RFEM, and then we call on some module to do the design. So until we do design, we do not use these options. Further down, you see that there are three tabs. There is a data tab, wherein the data that we use for the model gets updated. There is a display tab, which basically displays certain things which you require. For example, you want to display loads, you can check and uncheck from here. You want to display the member assigned, all the information, the stresses, the internal forces, all can be not the internal forces, not the results, but what we give as input can be uh, hidden and unhidden from here. And then there are views to give you a view of the certain views that you preset over here for your particular work. And after the analysis is complete, another new tab appears here by the name results. When we see as we progress in this video, we see this appearing later on. Let's go back to data. Then below here we have a table which says nodes, and then we have several tabs here which says lines, materials, surfaces. As we create new nodes, as we create new materials, as we create surfaces, the data in this table, in these tables, also get updated, and you can quickly export them into Excel using this icon. You can export them as Excel file, CSV file, uh, based on our requirement. Now this is the viewport, or the graphical user interface, which we use to create the model, manipulate the model, apply load, apply the boundary conditions. All are done through this very intuitive viewport. Now you might see that the background is black, which might be a little difficult for some of them. Personally, I do not like this black background. It is a little difficult to view at. So I can go into this option, display option, edit. We have this category called colors. We have this option called other. We have background. We check on the white option and we click OK, and we see that it has turned into white. If you prefer to use black, you can continue using its or if you want to change to any other color to your appeal, you can do that. Having said that, now let's create a simple 3D model. Now there are many ways in which the 3D model can be created. One easy way is to create model using the wizard. For that, click Tools, click on Generate Model. When we go through these, the software can create a huge variety of models using this wizard. It can create continuous beam, 2D frame, 2D tapered frame, 2D truss, grid, 3D frame, 3D hall, 3D truss, and 3D cells. For example, let's look into 3D frame. Now in this option, we see that using this option you can designate this number of spans in the X direction, Y direction, and Z direction. We can enter the span length over here. We can create the members and assign, and so on. Now let's try to create using the grid, using the wizard. To create a member in this drop down list, we do not have any sections that has been uh, imported. To import, click on this import button, click on I shape. Now when this dialog box appears, you see that on the left hand side there are a few filters. These filters gives us the list of standards or manufacturers groups that is available to us, from which we can choose. For example, ASTM is the standard, British BS is the standard. There are other companies here like Tata Steel, Tungho Steel, Max Steel. These are some manufacturers. This list actually lists some of the cross sections that they offer, which might not be available in the standard. Now let's choose AISC. In AISC, we have AISC 14 and 15. 15 is the latest one. AISC 14 is the one that most of you might be having with you. Now we have the entire list with us, but to bring it down to a few shapes, we can create a favorites group. At the moment, there are no favorite groups. Let's create a favorite group by the name group group 1. Let's select W shape. In W shape, let's uncheck all of them first and select a few. For example, let's select W14 by 99, and let's select a smaller one for the beam. Now click OK. Now we see that these two has been listed here in our favorites group. Now on the right hand side, we see the cross-sectional details of the beam that we have chosen, and also below we have a box which contains the material that is being used for the cross section. Now in this case, we have steel A992, which has been assigned by default. When you click this, you have concrete as well as A36. This A36 was imported by me. If you want to import one yourself, click on import material. On the left hand side, you have the standard. We have the ASTM, AISC 360. We have a lot of grades that has been designated in the standard. We can select any one of them. For example, we can say A53. If you want to import, click on OK. It has been imported here. Now for the time being, let's choose the default one, A992 steel. Click OK. Okay. Now for the girders in Z direction, that is the vertical one, 1499 has been chosen. Now let's import one more for the beam, that is W10 by 22. Let's give the steel property as A992. Click on OK. Click OK. Let's again use the W10 shape for the girders in Y direction. When we click here, we have assigned all of them. Insertion point is the point where we want the origin, that is this point. Let's give the number of spans. In the X direction, let it be 2. Let's make it like 3, and let the spacing be 15, for example. In the Y direction, let it be uh, uh, 20, for example. Let's have 2 of them there. And in the Z direction, let's have 3 with a spacing of 12. And we can customize. We can either enter the insertion point manually, or we can click here and click right over here, which is the origin. Click on OK. It automatically creates the 3D shape. Now let's add a few beams between these two beams. For that, let's create a few intermediate nodes on this particular beam. For that, click on it, right click on it, and go to member option, and that we have create node, create n intermediate nodes. Let's create 2 intermediate nodes. Click OK. 2 intermediate nodes have been created. When you look at it, you can see there are 2 of them. Now let's click on this, click on control, hold this node and copy it to this. Now we see that the member has been copied. Let's click on it again, press control, click on this node, drag it towards the next node. Now that has been copied. Now we need to copy this to the entire uh, frame. For that, let's select these two, click this node, drag it to this node. We have one copy. Click on control, drag it to this node. We have another copy. Now let's select all of these, click on control, you have a copy here, click on control, you have a copy here, you have a copy here. Now turn around, click on this one, you have a copy here, you have a copy in the inner one, and you have a copy right over here. Now we have created a few beams in the intermediate within the frame between two of these beams. Now we can see that when we created when we used the wizard, these supports were all pin. We could have changed it from there. Now let's change it to a fixed support. For that, we have an option called new nodal support. Click on it. We need rigid. Click OK. Now select all of it. Now it has all changed to a fixed support. You can right click on it. You can increase the size just so that you can view it better. Now having done these, now let's apply loads on the structure. For that, we need to create a few load cases. At the moment, this drop down menu is inactive because we haven't created any load cases yet. Click on new load case. In this load case, we have load case number 1. We need to make it right now. Let's create a load case called dead. In dead load, by default, the self weight is active, which acts in the -z direction. Now let's click on this button to create a new load case. Let's create a live load case. Click on live. Let's create another load case by the name wind and click OK. So we see that 3 load cases have been created. At the same time, a lot of load combinations have also been added. This is because while we created the model in the beginning, we had told the software to automatically create load combinations. Now, if you want to see the load combinations explicitly, click on this again, go to load combinations. The load combinations have been listed on the left hand side. Now what the software does automatically is that there are a lot of load combinations that's available in the manual or as per the ASCE standard. Now the software filters out only the ones that's required. For example, we have load case 1, which is a dead load, load case 2, which is a live load, and load case 3, which is a wind load. The program automatically chooses the combinations which only utilizes dead load, live load, and the wind load. Cases like seismic load, snow load have all not been considered. Now the one here up to this 2.31 and up to 2.32 is all from the LRFD load combinations, and 2.4 from 1 through 2 are all the ASD, allowable stress design uh, load combinations. Click on OK. Now let's apply the dead load. So go to the drop down menu, click on dead, and here we have tools. Go to generate loads, generate area loads on members via plane. So now let's take a look at this menu. We have a few options here. We need to apply a load in the vertical direction ZL. If you take ZP, we can see how the load application is going to be. Let's take ZL. Let's apply a load of 0.1. That is, now by default it is in plus Z direction. When you give a minus, it reverses the direction. Now you need to specify the corner nodes to apply the area load. Corner nodes to apply the area loads. Now click on this one. Either you can click enter the node numbers, but the easiest way is to click the corners of the area required. So click here, zoom in, click over here, 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 which closes this area. Let's create, click here, click here, click here. We need to just zoom in. We have a node. Let's click on control to change the view. We have a node right here. Zoom out, click here. So that creates the next area. Click here, click this button, click on this button. Now inside, you can see that the cursor snaps when you are somewhere close to the node. Now we have selected these areas. Click on OK. Now there is an option here to remove the influence of the load from some particular members. Suppose the members have been created such that you do not expect some members to take on the area loads directly. We can use this option to remove a few members. Either you can select the members one by one manually, or you can select this one to select one member, and all other members which have been selected using this tool parallel to the member will be removed from the influence. So select this. Let's select this member, and you can see that all members parallel to this particular member is removed from the influence of this surface load. Click OK. Click OK. Click on OK here. We see that the loads have been applied onto the area. Now we are not really clear onto which members the loads have clearly been applied. So for that purpose, click on one of them, right click on it, display separately. You can clearly see the load distribution on each and every member. We see that the members that we had excluded from the influence have been removed, and the loads are only applied on these selected members. Now let's add a live load. Click on load case number 2, live load. As before, go to loads, create loads, from area loads on members via plane. All these have been selected from the previous. Just change the value to say minus 0.5. Click on OK. Click OK. We see that now the load cases have been, now the live loads have been highlighted. If you just click on dead, we see that the numbers are changing. This is from the dead load, this is from the live load. If you want to see the load combinations, for example live load plus dead load, click on this. you want to see the 1.4 times dead load, you see that has been increased. If we take some other load combinations, we see that the effective, I mean the total load has been calculated and shown to us. Now let's apply the wind load. To apply wind load, go into load case wind, click on new member load, click on the option uniform, take a value of 0.25, click OK. Now select the members on which we need to apply the member line load. Press escape. Also, now let's add a trapezoidal member load for wind. So click on trapezoidal, change the value to say 0.1, click OK. Now select the members onto which we apply the member loads. Press escape. The moment we look at this trapezoidal load, we see that the higher load should be acting at the top. So this is because the member orientation is from bottom to top. To change it from top to bottom, either we can modify this load uh, by interchanging the values of P1, P2 from 0.25 to 0.1 and from 0.1 to 0.25, or we can simply change the orientation of the member. To change the orientation of the member, select all the columns, or at least the columns over here, right click on it in the member option. When they say it's 36x, it means all the 36 members have been selected. Just click on reverse member orientation and instantly the orientation of the wind load is varied. Now when you toggle through these load and load combinations, we see how the loads and load combinations are acting on the member. Suppose we take 1.2 dead load plus 1.6 live load plus 1.6 wind load, we see the entire load acting on the structure. Now let's move on into the structural analysis. To move into structural analysis, click on calculate all. Program does iterations to calculate the member forces, displacements, etc. Now we see the displacement profile inside caused by the dead load. Now at the same time we also see the load that's being applied. To hide these loads, click on display over here, move into the loads option, just click on loads and all the loads are hidden at the moment. Now we see the deformed shape because of the dead load. Click on this option, you can see the deformed load due to the live load. If you take it to the wind load, you can see how the wind load has deformed the structure. Now if you move into another option like say another load combination, you can see how the load is deforming the structure. Now at the same time, if we also now want to see the results in the form of internal forces, we need to move into results. In results, at the moment the global deformations have been ticked. Just click on it, which hides the global deformation. We have in member internal forces. Suppose we want the axial forces, click on it. We see the axial forces highlighted just near the member. if you want to see forces, if you want to see uh, the moment, for example, we can click on my, which shows the moment diagram in the structure. If you want to see and that is because of this load combination. Suppose let's take the dead load, the values uh, are varied. If you want to look into other moments such as mz, mt, all these values are available right over here. If we want to see the support reactions, for example, you can click on support reactions. You can click on the resultant. When you click on resultant, you can see that you can see the resultant force over here. If you want to see uh, px, py, pz, you can see it appearing right below here. So this shows the results of, you can explore through all of these options to find the reactions that you require or the internal forces that you require. Also, if you want to adjust the scale of the deformation or the output results, for example, the global deformation, you can see that this shows a much exaggerated view. On the right hand side, if you see, it shows 180. That means it has exaggerated the deformation 180 times. If you want to decrease it to 50, for example, click it reduces to a smaller value. You can adjust it over here. Now that's pretty much some information regarding the modeling, regarding load application, just an introduction to load application and structural analysis. After the next lectures, in the next lab, we will be moving into um, the design probably of a frame, and in the upcoming lectures we'll also look into industrial steel structures, design of industrial steel structures, the use of lateral braces all come into picture. We also will look into release, member end releases. For example, in this case we have assumed that the members are all rigid connections. We assume we can release the rigid connection to a pinned connection. All those details will be dealt with as we progress in the course.